at the Rapid Manufacturing Conference. Just entering. Doors just opening.
Okay, sir. 10 o'clock for you.
Oh, okay, sorry.
Go ahead.
Long bed. They're not opening up till 10. Get her early. So see the Rapid Manufacturing Conference starts in a few minutes. 3D printing. Hopefully we'll see some good displays, get some nice reading material. Conference goes in Detroit Tuesday to Thursday. I'm not sure, you might have to pay $100 to see the convention floor. So I'm not sure if it's still open or the price. It might be $100 just to go and see in the whole conference. It's actually kind of expensive, like $1,000. We'll have CEOs, experts on the field of various additive manufacturing 3D printing technologies. Hopefully we'll see some of the latest displays, some metal filament printers, plastic printers, probably 3D scanners. I haven't been to one of these conferences for a while. I had even been a member previous years of the SME Society of Manufacturing Engineers. I had went to this conference, I guess every year for a few years, and then I stopped going. So hopefully it'll be good. I'll do a little walkthrough, stream, talk through some of the technology, and then I'll gather some reading material. I have to be out of here by like 11:30, an hour and a half. So I'll probably stream for about an hour and about 30 minutes, and then I'll gather some reading material. Maybe I'll come back Thursday. They had the American CEO of Siemens Industry was a keynote speaker this morning, and I signed up for a few conferences over actually the next few weeks. They have plastic mold injection conference next week here, the same place. Then there's an Automate conference, and then there's also like a government fleet talking like mobility, logistics over the next few weeks, all in this same place. Tomorrow is the North American Steel Conference. That's in Novi. So hopefully I'll stream that also. Go to Novi for the conference tomorrow. I actually have kind of a busy week, so I would have I'm kind of paranoid about COVID. You can see, I got my mask on. Very few people are wearing masks. The COVID numbers are pretty high in Michigan. Over like 4,000 a day in Michigan. So the CDC has actually put a red advisory, and according to CDC guidelines, everyone here should be wearing masks. So God forbid this probably will be a mass spreading event. Death rates have been lower, less than 10 deaths a day, hospitalizations. So we'll see how bad this wave is if the case numbers go up, if it's not that deadly this time. But do it safe and cautious. I got my mask on. I'd estimate about 1 out of 25 people are wearing masks. There's no enforcement, no requirement. It is a CDC recommendation. Okay, so I talked a little bit on Week in Review, Church of Entropy, about the difference between additive manufacturing and 3D printing. I hope this week I will be able to write an essay on additive manufacturing. I think the first 3D printer came out in like 1990 at MIT and was a plastic extrusion, which is just an XYZ nozzle that melted plastic. You can go one layer at a time, melting plastic. And that was patented by MIT in 1990. There was patents earlier going back to the 70s for like the scintillation method that is more popular, although it wasn't built. So there are patents going back from the 1970s. The first 3D printer comes out of MIT in 1990. Under contemporary usages, I went to a Stratasys conference because actually the Michigan-Israeli Business Bridge, Stratasys was partly Israeli-owned, and that was like 10 years ago. And Makerbots, it's probably less than 20 years. I mean, the idea of 3D printing has been around about 30 years. They started reaching the market where you could buy a device about 20 years ago, and in the last 10 years they've reached industrial capacity where you could get a 3D printer that will be able to manufacture parts that are good enough for industrial use. And the market keeps on increasing, and so here you have a special conference. Okay, and we're in. Okay, so I'm going to do a quick walkthrough and keep on rambling. You can see it's pretty big, a lot of exhibitors, it's packed. I used to take pictures and post them on Facebook. I switched to live streaming. So a few years ago, it would have been just 1 or 2 booths that had 3D printers. And now the whole conference is dedicated to additive manufacturing. So pretty big transformation. I think I checked, additive manufacturing still makes up less than 1% of the industrial markets. So it keeps on growing. The growth rate's pretty big. Not like hundreds of percent every year, but a few percent, tens of percent each year growth. It's unclear how big 3D additive manufacturing will get, if it'll eventually reach even possibly 20-30% of the industrial market. Here's EOS. I have pictures on Facebook. I toured the EOS facility here in Metro Detroit. Metal filament additive manufacturing. So the basics of 3D printing are very simple. So just like a regular printer, a nozzle that moves in the XY plane in Z, but it'll do one layer in the XY, and then it'll go to the next layer and will literally print a part. And there you can see like spools of plastics that are melted through an extruder. And so the basic, like in 1990, the first MIT 3D printer was pretty simple. So you could even build in like a high school science lab class a 3D printer. It's not like a simple robot that takes commands to operate on an XYZ plane, and an extruder with some sort of heater that will melt the plastic. And that's like this, your simple. So here it's just like XY plane, and then it has a platform that goes down. So you could have an extruder that moves X, Y, and Z, but most of them don't operate like that. The extruder will just move like this on the XY plane, and then the platform will move up and down on the Z plane, and that will allow a full 3D printing. And that's actually not the dominant method. It's not the most precise. Most of the modern industrial 3D printers don't operate that way. and it's not even accurate to call them 3D printers. That's why it's called additive manufacturing. And there's different forms of scintillation, where basically they'll have two lasers they'll have like a powder bed of the material that fuses when it's hit by two lasers. And so the laser will hit the area, usually on an XY plane, and moving one layer to the next, causing the powder to fuse. And then the platform will usually be lowered, and it'll do it on everything that needs to be fused on one plane will be fused, and then the platform will be lowered, and again the process will repeat, and that I think is referred to laser scintillation, and that I believe is more accurate. I'll get some of the reading material in a bit, and after I do a walkthrough and some of the streaming. Fine metal filament printing works in different ways, and they're different material. A lot of the fine metal filament printing will also use laser scintillation. Like I said, where either one or two lasers, usually two lasers, where one laser itself hitting the point isn't enough to cause them to fuse, so it has to have two lasers fixed on the same point, and that will cause the powders, even the metal filaments, to fuse together. And there you see very simple old style 3D printer, and this one's nice, but you could even make this in like a science high school science class, like a simple plastic spool fed 3D printer. The concept is not that complicated. Here they have open model one. Just a simple nozzle extruder and a heating element that melts. And so now there's hundreds of companies that make 3D printers, additive manufacturing technology. I think the bottom of the market, the bottom of the market price for a fine element metal printer, I think they said is $90,000. So a few years ago it was a few $100,000. Prices are coming down, and so you're talking about being able to make metal pieces. You're still talking like at least $100,000. You could get a cheap 3D plastic printer already for probably $500. And it wouldn't be very accurate. Maybe like $2,000. You could get a semi-decent 3D printer, like a Makerbot or some of the competitive lines. For industrial use, you're talking about tens, hundreds of thousands of dollars, and you're talking about printing parts that are going to be certified for industrial use. So that would usually not be a simple model, like the old school Makerbots like these that would make one part at a time. A lot of those you'll have bigger beds and would be able to make multiple parts at a time, 20 at a time. And for industrial use, you'd want one that would be able to make hundreds and hundreds of parts, and thousands, hundreds of thousands of parts. And so now some of the manufacturing facilities might have Atheist Pundit. Thanks for joining in. Yes, I'm just here in Detroit at the manufacturing conference, showing the latest 3D printer additive manufacturing technologies. A lot of cool stuff here. A lot of this is extremely expensive equipment. Some of it costs millions of dollars. Even on the cheaper end, like these ones would still cost thousands of dollars. Even these simplified models would still be thousands, tens of thousands of dollars. But this is for industrial use, and you're talking about products not something that you'd have on your desktop. So originally, 3D printing was mostly just used for modeling, research and development, and making a part to test. And so if you had a design of a single part that you just wanted to build one single object model of, to make the first model would be expensive, the old school methods of plastic mold injection. You'd have to actually build the mold just for one model. And actually next week is here in the same room is the conference on plastic mold injection. So you see HP has got one of the biggest makers of printer has gotten into the 3D printing and metal filament printing, a lot of different systems. So when they first came out with 3D printers, it was mostly in the realm of like research and development. I was going through these conferences from the very beginning. So like Ford, when it was expensive, the first 3D printers would have a few 3D printers in their research and development labs. But as the technology has improved, it's actually replaced manufacture for certain devices. So I'm not sure if this is a printer. So here you see large-scale 3D printers. Here you're talking a huge machine, and I think this is still plastic or wood. So it's actually quite a few different materials that could be printed like this. You could even print houses. So think like a desktop Makerbot type model that would be like a foot by foot that would sit on your desk and be about the same size as a normal printer, or it's an industrial grade machine. And as I said, most printers will go across a surface and will completely do one layer, and instead of having the nozzle on three axis, XYZ will just be on the XY axis, and then the floor is raised or lower, so we'll do one complete layer at a time. And so for industrial use, you're more likely to have multiple parts printed at a time. And so maybe I'll even come back Thursday if this video is well received. I'll get some reading material and try to come back Thursday and see more demonstrations. I'm in a little time crunch today. There's a connection between 3D printing and 3D scanning that now you could get a digital image. So the 3D printer uses there's actually complicated, I'm not sure I'll be able to talk about it while I'm walking around, with the mathematics of the model. So if it used like a CAD file, which is mathematical formulations of a 3D image, or you're talking like a PGN, a picture file where you just have a graph of a dot here or not, and but either way you have a 3D image, and it said the printer will go on one layer of the XY plane and will extrude a certain amount of part that's supposed to be there, and then it'll go to the next layer and keep on doing that. And so it's based on a three-dimensional image, and you could, like, the Siemens has a SolidWorks. There's I forget the French company, Dassault, something I think of it. They're probably here. There's many companies that have the software, and a lot of them are here, the software companies, to model 3D images. So the 3D images would be created in a mathematical model, and
is him talking.
So the reverse kind of sister technology of 3D printer is 3D scanning. And basically that's just a scanning technology that will scan an image and scan an object and create a three-dimensional object based on the image that was scanned. And so that reverse engineering of scanning an object, then it could be printed. And you could also print like circuits, electrical circuits, various things. Here's a machine that has Multicolor, a simple plastic 3D printer. As you see, it moves on the XY axis, and then the bed moves down. So this is the most simple basic model. It here has two colors fed in. You can see very clearly a blue and a yellow plastic filament fed in, and there would be a heater. It melts it, and it goes one layer, and then the bed moves down, and it does the next layer. And it gets a little bit more complicated with support elements for the structure, because a lot of times if you've used a 3D printer, the object will collapse in on itself due to the weight, and you have to print support structures that have to be torn away after, and like metal filament printing requires you have to sand it and various things, so it's not as simple a process as you just hit print and then you get your object. So it's not quite that simple, but so pretty cool. You can see lots of the latest huge machines. Same here, you have just a huge 3D printer. I guess it's open, and you see the bed. So they started on top, and this bigger objects than me. You can see the bed starting on top. The bed will go down, and who knows how big of an object, but it could print. Oh no, I'm just screaming a little bit. Is this metal or plastic?
It's a polymer base, but it's an entirely different system. It's not an FDM, SLA, or SLS system. It's called GDP, Gel Deposition Printing. It's the only company in the world that makes it, and the only company in the world that invented it.
Awesome. I'll come back. You have reading material?
Yeah, I can scan you. We can get it sent to you.
I would appreciate that.
Wait a second. Where are you out of? Right here, Southfield?
Yeah, local civil engineer.
You say civil for building infrastructure, the rest, kind of seeing
More
what's available?
construction, more just a technology geek.
There you go. I'll make sure you get some info.
Appreciate that. So they actually have companies that will 3D scan people, and you could make a model of yourself. You could scan yourself and then have yourself printed. But most of these are for industrial use. That there's also for like movies, Hollywood, Bollywood, for special effects, where sometimes they'll 3D print. Civil engineering actually has a decent use of 3D printing for like GIS, global information, but topographical maps of detail. So if you wanted to print a scale model of the city, or just a surface, if you wanted to know what was going to be on the surface, and like the height, water, various things, that 3D printing is also a very good way of getting the detail. And it said the sister technology of 3D printing is 3D scanning, and for something like that you could use satellite information or helicopters, laser, to get a larger topographical scan and then print it out. So I'm in a little bit of a crunch for time today, so I'm going to wrap up the stream. Maybe I'll come back on Thursday if time allows, and I'm going to collect some reading material. So, anyone tune in, appreciate tuning in. God bless, stay safe. And I signed up for multiple conferences over the next few weeks. So tomorrow, hopefully also I'm going to make it to the Steel Conference in Novi. And maybe I'll come back here Thursday. Next week, there's the Fleet Conference of vehicular fleets, and the Plastic Mold Injection Conference. And I think they're concurrent, so I'll probably try to hit that in the same day. And then I think the week after is the Automate Conference on robotics. So thanks for tuning in. Blessings. God bless. Have a great day.